So today we're starting chapter 4, which we will have a quiz before Thanksgiving on this. I am giving the quiz on Tuesday, not on Wednesday, since Wednesday is a 2-hour early release. And we'll have shortened periods, and some of you might not make it to school that day. So I figured Tuesday was the best day to give a quiz. Sorry if you have other quizzes in your classes, but I'll give you the heads up now. We will have learned everything by this Friday, so if you want to study over the weekend, you can. Chapter 4 deals with triangles and congruent triangles for the most part. So today we're looking at just what congruent figures are, and we'll be able to identify them and also their corresponding parts. So, congruent figures. Congruent figures are two figures that have the same shape and the same size. So for example, a triangle and a quadrilateral could never be congruent. They're not the same shape. They'd also have to be the same size, meaning they have the exact same side lengths and they have the exact same angle measurements. Congruent figures are going to have congruent corresponding parts. So we talked about corresponding angles, right? Corresponding angles. We looked at parallel lines. We said corresponding angles were in the same relative location along the transversal. Corresponding parts are going to be in the same relative location of both triangles. We're also going to see what's called a congruent statement. So for example, triangle ABC is congruent to triangle DEF. The corresponding parts will match up, like the first letter will correspond to the first letter. The second letter, so if I were listing the angles that were congruent in this triangle, angle A would be congruent to angle D. Angle B to E, and C is congruent to F. Also, you could look at the sides. AB will be one of the sides of the triangle. DE will be one of the sides. So you can identify congruent parts by looking at this congruent statement. But those are called corresponding parts. Okay, just like corresponding angles, they're in the same location. All right, so these figures are going to have the corresponding parts will be congruent corresponding angles, and they'll also have to have congruent corresponding sides. And you can use the congruent symbol if you would prefer. But they have to have basically 3 pairs of congruent angles and 3 pairs of congruent sides to be congruent. We will learn shortcuts for proving triangle congruence tomorrow, but for today we're going to have to prove all the sides are congruent to all the sides, all the angles are congruent to all the angles. And when you're writing out this congruent statement, you do want to make sure that you always list the vertices in the same order. Okay, the order will matter. How you name the first one doesn't matter, but you have to make sure the second one matches up with the corresponding parts. And you'll see what I mean in one of the examples below. So naming congruent parts. Again, we can use this statement. And we'll notice that if 2 triangles are congruent, then their corresponding parts must also be congruent. And we will have 6 pairs of corresponding parts. We'll have 3 pairs of angles and 3 pairs of sides if it's a triangle. Example 1 asks us just to list all the corresponding congruent sides and congruent angles. Now notice we are given this congruent statement. You actually don't need a picture at all to do this. Okay, so the picture is actually irrelevant. You can just look. The first 2 letters would be side AB are going to be congruent to the first 2 letters side DE, which we will use a segment bar because these are going to be segments. Do the second letter and the third letter. So side BC, segment BC, will be congruent to segment EF. And if you want, we could mark these in the picture as we're doing it. So AB would have 1 marking, DE would have 1 marking. Those are congruent. BC, 2 markings, EF, 2 markings. Sometimes they rotate and flip the picture, so it's not as easy to look and identify. Some of you are like, oh, that's the small side, that's the medium, and that's the longer side. But whenever it's rotated and flipped, sometimes it's hard to tell. So that's why you always want to use the congruent statement if you're given one. Last one would be the first letter and the last letter. So segment AC is congruent to segment DF. And that would be our third side. And I'll put 3 markings. So those are the corresponding congruent sides. Now we have the corresponding congruent angles, which, since we're given a congruent statement, I would just look at that. Angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. So if you're given a congruent statement, it's super easy to just identify first with first and so on. All right, now this one, they tell us the triangles are congruent. We want to name the congruent triangle based on the given. I'm going to do the first one with you, and then I'm going to have you do the next one. Now, you'll want to pay attention to markings, because we're actually writing the congruent statement. So the first one says triangle ABC. So you might want to look at the markings. It has a 1 marking with A. It has a right angle marking at B. And at C, it has 2 angle congruent markings. So if you want, you can jot those down. The letters that you pick for the other side have to be in the same corresponding order. You can't just pick any random order and put the letters there. So you'll have to start with the one that has a 1 angle marking, which is angle E. So this would be triangle E. The right angle comes next, which would be D. And the 2 angle marking comes next, which would be F. You can see they already put the triangle symbol for us, otherwise we'd write that. See if you guys can complete the next 2 congruent statements. Again, you might want to use this little trick where you write letters and numbers above to help you kind of keep in order, but if you think you can do it without, try the next. The third one. DFE. DFE. Perfect. Again, just paying attention to the markings. If they don't have markings in, you would want to add them if some of them, maybe the third angle wasn't marked, which we're going to talk about right now. New theorem, the third angles theorem. What the third angle theorem tells us is that if you know 2 angles are congruent to 2 angles, you can conclude that the third angles have to be congruent, and that's basically because of triangle sum. So if angle A is congruent to angle D, and angle B is congruent to angle E, then angle C has to be congruent to angle F. And I'll just do a little mini proof using numbers for you guys. This is not going to be drawn to scale. But let's assume that angle A and angle D were both 30 degrees, right? Let's say angle B and angle E were both 50, because we are given that they're congruent, so I'm just marking them congruent. So if we were to use triangle sum, we could say 50 plus 30 is 80, 180 minus 80 tells me that this would be 100. And then same thing here, because of triangle sum, you can conclude that that would be 100. Therefore, they are congruent. So without having to use triangle sum and prove that, because we're not going to be given angle measurements, we're just going to be given markings or told that they're congruent, this is a really useful theorem. Okay? When you write it out, you can either write it out like this, or you can write third angles theorem. Because I know we like to shorthand in our proofs, right, as much as we can. So you can abbreviate third and your angle. All right, so sometimes we'll have to use that also in some of these problems. We're going to start out with just some yes/no questions. Are the following polygons congruent? Remember, for them to be congruent, all their sides have to be congruent. Their corresponding sides have to be congruent. And their corresponding angles have to be congruent. So all congruent sides, all pairs of congruent angles, we have to prove all of them in order to say they are congruent. Now some of them are common sense. Is the first one a pair of congruent triangles? Just look at them. Do they look like they're the same shape and size? No. They're different sizes, so no. It does ask me to explain, so I would say that either they are different sizes, or we could say that their corresponding sides are not congruent. corresponding sides are not congruent. You can see the angles are congruent, right? One marking, 2, 2, 3, 3. But the sides are not. These are not congruent figures. Does anyone know what they are called? They are a type of figure. No. Similar? These are similar figures. And we'll talk about those later in the year. Similar figures are something that have the same shape but different sizes. And they have to be proportional. So like 10 divided by 2 is 5, 12 divided by 2 is 6, and 14 divided by 2 is 7. So the ratio is a 2-to-1 ratio of the two triangles. But you don't have to know that yet. All right. Now the next one, we have a pair of quadrilaterals. Okay, they just happen to be touching. So we can see this is marked congruent to this. This is marked congruent to this. This has a 4 and this has a 4, so those are congruent. This is not marked congruent, but would we know JK is congruent to JK? Would we know that? Can we conclude that? Yeah, it's the same length in both sides. Does anyone remember what property allows me to say that something is congruent to itself? We had transitive, symmetric, and reflexive. Which one is it? Cookies? Yes, this is your reflexive property. So when you get into some of the proofs below, you're going to use the reflexive property anytime you have a shared side. So a side that is shared among two different shapes, you can conclude that it is congruent to itself because of the reflexive property. We always thought it was the stupidest property because we obviously know 2 equals 2 or angle K congruent to angle K. Like, why would I ever say that? This is why. When you have two shapes that are butted up right against each other and they share a side. Okay, so now we have all the sides are congruent, the pairs of sides. Now let's check the angles. We have 90, 90, 90, 90, but we have 60 and 120. So right now it looks like I don't have congruent angles. However, how many degrees are inside of a quadrilateral? What is our quad sum? Triangles are 180, quadrilaterals are 360. So let's go ahead and say, we know there's 360 degrees total in each of those shapes. So if I take 360 minus 90, 90, and 60, what do I get? We do get 120. And if we take 360 minus 90, 90, and 120, we will get 60. So we can conclude that these are congruent. Now, they want us to write a congruent statement. So again, it does not matter how you name the first shape, but the second shape has to match up with the corresponding parts. So for example, maybe I'll start with the 60, then I'll go 90, 90, and 120, just to go like small to large. So I would say, when you do a symbol for quadrilateral, usually you just draw like a little four-sided object, kind of like a parallelogram. And so I'm going to say HKJE. Again, if you were writing this, you could write the first one in a different order. It doesn't matter. The second one depends on how you write it, though. Is congruent to quadrilateral. Now we have to make sure they match up. This was the 60-degree angle, so I have to start with the 60-degree angle and then go in and up. So this would be G, K, J, F. Usually on your quizzes, I'll put the first one for you. That way your second one has to go in the same order as mine. Otherwise, it takes a lot longer to check. Okay, so those are congruent polygons because all of their corresponding sides are congruent and all their corresponding angles are congruent. All right, the next one. We notice 3 and 3, which means they're congruent, 4 and 4, which means they're congruent, and the markings tell me, so we know that all the sides are congruent. So that's a check. 3 pairs of congruent sides. Now the angles. Right now it tells me one angle is congruent to the other, A and E, B and D, but we don't necessarily know those are congruent, or do we? How could I conclude that those are congruent angles? There's 2 possible answers. And we cannot call this angle C because it has multiple angles. So I'm going to jot down just to get you guys kind of ready for proofs. You would call this angle BCA or angle ACB. Do you remember naming angles earlier this year? Use 3 letters. So BCA would be congruent to angle ECD. Because why? There are two possible reasons you could list. What type of angles are they? Katie? They are vertical angles. They're formed by two intersecting lines. And they're opposite. So you could say the vertical angles theorem. Or what's the theorem we just learned on the front? The third angles theorem. If you know two angles are congruent to two angles, the third angles have to be congruent. It doesn't matter which one you use, but both of them would be acceptable. So now let's mark that. Put 2 markings and 2 markings. So we absolutely can say that these are congruent. So again, when you're writing the congruent statement, you can write the first one however you want, but usually I'll go like 1 marking, 2 markings, right angle, or 1 marking, right angle, 2 markings. Let's go alphabetical. ABC. Triangle ABC is congruent to, who could name the other triangle correctly, matching up our corresponding parts? Triangle ABC is congruent to triangle, Maddie? EBC, good. Very nice.
Pardon the interruption. Mrs. Lasso, please dial extension 6503. Mrs. Lasso, 6503.
All right. Example 4 tells us that the triangles are congruent. And again, anytime you're given this congruent statement, make sure you pay attention because this tells you what the corresponding parts are. Find the values of the variable, should say plural, variables, based on the fact that these are congruent. Now, some students like to go mark based on the congruent statement. So KL has to be congruent to DW. So KL and DW. 1 marking, 1 marking. LP and WH. LP, WH. And then obviously KP and HD. And then if you want, you could also mark the angles if you think you need to. Angle K has to be congruent to angle D. So right off the bat, before I move any further, if this angle is 51 degrees, this one also has to be 51 degrees. So I would copy that over there. All right, we can also see that angle L would be congruent to W. So angle L is congruent to W. So if this is 74, that's 74. And then I'm not going to mark the last one because we would know it is congruent, but if this is 5x, this is also 5x. So see if you guys can find the value of x and of b using that fact. Find the value of x and of b. This is a b. All right, who can tell me what they got for x? What was the value of x? Karen?
11.
X is 11. Very good. You should have subtracted and divided to get 11. Again, using triangle sum to find that out. And then what was b? What was the value of b? 80? 2. So we noticed that this was marked as being congruent to this. So if this is 4b units, and that's 8 units, those have to be equal since they're congruent. And then just divide by 4 or figure out that it would be 2. All right, the last one is a fill-in-the-blank proof. A lot of these will be given. So in these proofs, they sometimes break up the given. They don't put it all on line 1 because you're going to be given, as you look at the picture, there's lots of stuff that was given to us in the picture. So sometimes they don't dump it all in the first line, they break it up. It's up to you when you do your own proofs if you want to put it all together or split it up. So if you look, it says segment DL is parallel to SQ. You can see that that's marked in my picture. So I would write down in my proof, given. And we know that with parallel lines, oftentimes it's useful to highlight them because they'll give us a type of angle that we might know from parallel lines. All right, now always make sure you trace the angle and don't just look at the picture. It says angle LDQ. So take your pencil, LDQ is talking about this angle here, which I'm going to put 2 markings since one of the angles already has 1 marking. So LDQ is congruent to angle SQD, so I'll put 2 markings there. Why are those angles congruent? Why are those angles congruent? Joseph? Perfect. These are alternate interior angles. So you're either going to write out alternate interior angles theorem, or you're going to write if lines parallel, AIA congruent. So a lot of the stuff we did in chapter 3 is going to follow us into chapter 4. And actually, we're going to go back all the way to chapter 1 when we looked at segment bisectors, midpoints, and all that kind of stuff. It's all going to come together in this chapter. All right, next one says angle L is congruent to angle S. So let's go look. L and S were actually marked in the given picture, which means those were given to me. So that's given. Next one says angle QDS, QDS, which would be this angle, which you can either put 3 markings, or if you kind of can't see that well, you can also put like a slash through it coming out. If you ever want, you can use that and that as like different markings. But I'm going to do 3. Is congruent to angle DQL. Why are those congruent? Be careful. There's actually only one correct answer for this. It's a theorem that we learned today. Marquise?
That's alternate interior angle.
No. Yes, these are alternate interior angles, but we do not know that these are parallel. Kel?
Third angle theorem.
It's the third angles theorem. So since we know 2 angles are congruent to 2 angles, we can conclude that the third angles are congruent by the third angles theorem. You cannot say alternate interior angles theorem just because we, again, don't know that those are parallel lines. We only have one pair given to us. All right, next, segment LD is congruent to segment SQ. There was a marking on my picture, and DS is congruent to LQ, so that was given to me in the picture. Last one says segment DQ is congruent to segment DQ. Why is that? DQ is congruent to itself. Justin? Reflexive property of congruence, technically. Very nice. So now we have proven that all the corresponding sides are congruent to all the corresponding sides, all the angles to all the angles. Does anyone have an idea of what our last reason would be? It'll be a definition. Congruent figures have congruent corresponding parts. We proved that they have congruent corresponding parts. So your final answer is either going to be the definition of congruent figures or polygons, or most of the time they're going to be triangles, so I usually say definition of congruent triangles. But I probably have both here. Definition of congruent triangles or polygons. The definition of a congruent polygon is that it has all congruent sides and all congruent angles in terms of corresponding. All right, see if you guys can answer the closure question while I'm passing out the homework.
Please and thank you.